Now let us discuss long answer questions from chapter number 6. We have already discussed about weightage of the syllabus. In that weightage we have seen that in chapter number 6 there is a long answer question. వర్క్ ఎనర్జీ అండ్ పవర్ చాప్టర్ నుంచి మనకు 3 లాంగ్ ఆన్సర్ క్వశ్చన్స్ ఉంటాయి. ఆ 3 లాంగ్ ఆన్సర్ క్వశ్చన్స్ నుంచి ఏదైనా ఒక లాంగ్ క్వశ్చన్ మనకు యాన్యువల్ ఎగ్జామ్లో వస్తుంది. ఓకేనా? ఫస్ట్ క్వశ్చన్ ఏంటి అని అంటే, డెవలప్ ద నోషన్స్ ఆఫ్ వర్క్ అండ్ kinetic energy and show that it leads to work energy theorem. It leads to work energy theorem. Okay, now this is a question. Develop the notions of work and kinetic energy and show that it leads to work energy theorem. Okay, this is the long question, 8 marks question. Now for this let us see the answer. Okay, so question lo clear ga define the notion of work annadu, so kinetic energy annadu. Kabatti first work ante endo తెలుసుకొని డెఫినేషన్ రాసి తర్వాత కైనెటిక్ ఎనర్జీకి వెళ్ళిపోదాం. ఓకే, స్టెప్ బై స్టెప్. వర్క్ అని అంటే యాక్చువల్లీ వెన్ ఏ ఫోర్స్ యాక్ట్స్ ఆన్ ఏ బాడీ, ఓకే, వెన్ ఏ ఫోర్స్ యాక్ట్స్ ఆన్ ఏ బాడీ, if it displaces from one place to another place, from one place to another place, then we say that work is said to be done. So when a force acts on a body, if it displaces from one place to another place, then work is said to be done. How will define in a mathematical form is work nothing but W is equal to force into displacement. Okay, force into displacement. Okay, so W is equal to F into S, nothing but product of component of the force and in the force in the direction of the displacement and magnitude of the displacement is called work. So W is equal to F into S. Okay, now we go for kinetic energy. Kinetic energy. Okay, now we have different forms of energy. Among them, this kinetic energy is one type of energy where we can define this kinetic energy as the energy possessed by a body due to virtue of its motion. ఓకే, ఏదైనా ఒక బాడీ మోషన్లో ఉన్నప్పుడు అంటే చలనంలో ఉన్నప్పుడు ఆ బాడీకి కలిగి ఉండేటటువంటి శక్తిని కైనెటిక్ ఎనర్జీ అని అంటాం. సో ద ఎనర్జీ పొసెస్డ్ బై ఏ బాడీ డ్యూ టు ద వర్చ్యూ ఆఫ్ ఇట్స్ మోషన్ is called kinetic energy. Is called kinetic energy. Okay, where it will have an expression like kinetic energy Ke is equal to 1 by 2 mv square, where m is the mass of the body and v is the velocity of the body. Okay, so in the question it is given work, we have discussed work, and kinetic energy is given. So kinetic energy we have discussed. Now we will go for work energy theorem. Okay, Now work energy theorem, nothing but we'll discuss first statement of work energy theorem statement. Okay, now suppose that if we consider a body of mass m, now it is moving with an initial velocity u. Now a certain force F acts on a body, then it will reaches to a new place, means it will displaces to a new place, and that displacement is say s, and this body of mass m will attain a final velocity v. Okay, now we are considering a body of mass m which is moving with an initial velocity u. At that moment a force F acts on a body such that it gains a final velocity v and displaces through a distance s. Okay, right. Now as it is moving, there will be a kinetic energy for the body in the initial stage and even in the final stage, where here we call this as initial kinetic energy Ki, nothing but half m u square, u here will get. Now and final kinetic energy half m v square. Now that is the final kinetic energy half m v square. Now we say that whenever an object is moving and a force F acts on a body, then there will be change in the velocity, and that change in the velocity leads to change in the kinetic energy, and that kinetic energy is always equal to work done by the net force. Okay, that is the statement of work energy theorem. What is that? The change in kinetic energy, the change in kinetic energy is equal to the work done, is equal to the work done by the net force, work done by the net force. Okay, now change in kinetic energy means in a first is kf, means final kinetic energy is kf. We'll take, now from this we'll subtract initial kinetic energy ki, so kf minus ki, according to statement we write this as w. So kf minus ki is equal to w is the statement for work energy theorem. Now we need to prove it. Okay, let us prove this statement. To prove this work energy theorem, let us consider an equation. We have v square minus u square is equal to 2as, which is the equation of motion, where u is the initial velocity, v is the final velocity, a is the acceleration, and s is the displacement. Okay, now we need to multiply the above equation with m by 2 on both sides. Okay, now let us multiply this one, m by 2 v square minus m by 2 u square is equal to m by 2 into 2as. Okay, now right side 2 gets cancelled with each other. Now we can write this as half m v square minus half m u square is equal to m a s. Okay, but according to Newton's second law, ma can be written as f. Okay, now we'll replace this one here. So half m v square minus half m u square is equal to f into s. Okay, so equation number 1. Now this above equation leads to the definition of work energy theorem, means statement of work energy theorem, where we have this is the final kinetic energy. Okay, here we have discussed final kinetic energy, and this one initial kinetic energy kf and ka. If we replace here, so kf minus ki is equal to f into s. Okay, or we can replace this kf minus ki as f into s, nothing but work done. So kf minus ki is equal to w. Okay, where the terms have their usual meaning: initial kinetic energy, final kinetic energy, work done, and which is the statement for work energy theorem. This is the proof.